Welcome to today's training on the Matrice 300 RTK and Zenmuse H20 series. Built tough, work smart. Today we're going to be running through performance of the system, safety and reliability, advanced intelligence, extensibility, and openness. So working into the performance side to start things off. When considering flight time of an aircraft, it is a known law that as you're increasing the payload weight, there will be a decrease in total flight time, and that's no different with the Matrice 300 series. When equipped with the H20T camera, can expect 43 minutes of flight time. If the aircraft is not equipped with a payload, can expect up to 55 minutes of flight time. If you were to have the maximum load of the aircraft, which is 2.7 kilograms, the maximum flight time would be 31 minutes. But overall, obviously a common question in regards to any aircraft is how long it can fly. When a flight is complete, obviously charging the batteries is what comes next in play. The Matrice 300 RTK utilizes a fast charging battery station called the BS60 battery station. This station can be used for both charging and storage and transportation of batteries, holding up to 8 TB60 batteries, which will go in the aircraft, and 4 WB37 batteries, which can be used with the remote controller or DRTK2 base station. You can charge 2 TB60 batteries to full capacity within 60 minutes, and also charge the WB37 batteries at the same time. The aircraft does utilize 2 TB60 batteries at a time for flight. In regards to transmission between the remote controller and the aircraft, when following FCC standards, the max transmission range in areas without interference is measured to be up to 15 kilometers. This system supports 1080p HD image transmission and triple video channel support. So in this case, you can have multiple operators receiving different video feeds or a single operator receiving different video feeds from the FPV camera and payloads that are attached. Speaking of the payload systems that go onto this aircraft, it can hold up to 2.7 kilograms with a maximum takeoff weight of 9 kilograms. Supports up to 3 gimbals and multiple payload configurations. You can reference our Matrice 300 user manual in regards to which payloads can be configured on the aircraft at the same time and in which position. Our DJI payloads include the H20 series, the H20N, the P1, and the L1. In today's training, along with the Matrice 300, we are covering the H20 series. This H20 series has two versions, the H20 and the H20T. You can remember the H20T being different because the T stands for thermal. Both sensors include a wide, which is the smaller visual sensor here, the laser rangefinder, where you see a reflective rectangle visually on the outside, a zoom camera, and then additional thermal camera for the H20T. The zoom camera is a 20 megapixel camera with 23-time hybrid optical zoom. The equivalent focal length of this camera is from 31.7 to just over 556 millimeters. The thermal camera is radiometric, 640 by 512 resolution with a frame rate of 30 frames per second. The laser rangefinder utilizes the 905 nanometer wavelength and has up to a 1200 meter detection range. Can utilize the formula to determine the margin of error for measurement. The wide camera is 12 megapixels and has an equivalent focal length of 24 millimeters. Overall, as an operator, these different sensors serve different purposes and allow the operator to efficiently carry out operations, and collect data from just one camera or all three at the same time while measuring location or distance information with the laser rangefinder. See the UI of the Pilot 2 app with the H20 series on the right here within this video. You can quickly switch between the wide view, the infrared view, and the zoom view. The top of the screen shows which camera view is currently being utilized, while the bottom of the screen carries more important information we'll get into later. Showing off some of the zoom capability here, we can see 2 times, 20 times with that hybrid optical zoom, and up to 200 times digital zoom here as we zoom in on the sign. This is about 400 meters away. The thermal camera allows the operator to switch to different color palettes, adjust the isotherms if the operator would like to focus on a specific temperature range, along with other tools. You can see on the right side here, the camera also supports temperature measurement by tapping on the screen, or an area measurement by tapping and dragging to create a rectangle. Within this rectangle, you can turn on temperature alert. So as the drone was flying, whether that be over power lines or in a search and rescue situation, the operator would be alarmed by a verbal alarm from the controller in regards to a temperature that exceeded the max value input by the operator. The laser rangefinder is able to give the operator the distance away from the aircraft. And then on the map view, you can see exactly where the camera is looking. In the bottom left, you see a GPS location of what the camera is looking at, as well as altitude information. So once again, if you need to get a location during an operation for communicating with a team, that can be easily done for doing a search and rescue mission in the mountains. Or once again, after an inspection, if you'd like to see where the component was that was being looked at, instead of looking at the drone location, by utilizing the laser rangefinder information, you can see where exactly the photo is. Moving into safety and reliability of the aircraft. As with any aircraft, for a pilot, being comfortable with the system is a very important factor. The Matrice 300 RTK has 6 directional sensing and position with 2 visual and time of flight sensors on all 6 sides of the aircraft. And when I say 2, that is referring to the visual sensors, the time of flight sensors, though you'll see 2 ports on the drone itself. That is for the time of flight sensor to push LiDAR out, and then for it to come back in. It has up to a 40-meter max detection range with those visual sensors that can be customized within the app in regards to when you would like the aircraft to notify you of an obstacle and when the aircraft should stop. There is anti-collision beacons built into the aircraft on top and bottom for visibility or night flight regulations. And there's also auxiliary lights built into the top and bottom of the aircraft, which helps with landing and or visibility as well. IP rating is important for operators who can't always dial up to the weather to ideal conditions. The drone itself has an IP45 rating, which protects against the intrusion of solid objects and splashing water. And the H20 series carries an IP44 rating, protection against the intrusion of splashing water in all directions. Overall, the system is built with a tough, rugged, and a reliable outlook with the ESCs, or electronic speed controllers, located in the body of the aircraft, external airflow design, and the ability to withstand rain of 100 millimeters per 24 hours based on testing within the laboratory environment. Within the Pilot 2 app, the health management system is a key tool for operators to determine if there's any issues before, during, or after flights. As you see in the screenshot on the right side, you have the different components of the aircraft, including propulsion, avionics, vision positioning, battery, remote controller, and image transmission, to name a few. By just taking a quick look at the health management system, you can see if there's any issues and investigate what those are. You also have easy access to flight data and flight logs if those need to be shared with the DJI after sales team for analysis, along with the ability to easily upgrade firmware. Furthermore, after a flight, if there was an error that came up, you can go back into the health management system to review that error and complete any necessary troubleshooting. Redundant systems are another key safety feature of the aircraft, including dual IMUs, barometers, compasses, and RTK antennas, which include GNSS modules. The aircraft also supports dual control, where either operator, when utilizing two remote controllers, can fly the aircraft and take that aircraft control. Can also have one operator flying the drone and the other operating the payload. Overall, this creates new possibilities for long linear missions or dynamic scenes where the operators have the option to choose the best operating scenario for their team. As we talked about, the drone itself does utilize two TB60 batteries at a time. This redundancy is useful that even if one battery were to fail, the drone can still return to home safely. You can see in the video here on the right side, the three propeller emergency landing in action. If we have a failure of one of the motors or ESCs here, the operator can maintain control of the aircraft and still bring it into a controlled descent and make sure the drone is coming down in an area that is best given the operating environment. So once again, an emergency scenario here, but being able to guide the aircraft in case of this emergency is a big plus as an operator. The drone itself also has an FPV camera built into the front of the aircraft. So this allows the operator to maintain situational awareness. We'll show a screen recording from that shortly as well. And the drone itself has an ADS-B receiver and alerts the pilot within the Pilot 2 app of any aircraft in the area that are broadcasting ADS-B information so they can take proper evasive action. For those operators who do not want to connect their device to the internet, we support offline updates so you can utilize the latest features and fixes for the aircraft and payload. You can download the firmware, put it onto an SD card, insert that into the remote controller, and create a firmware update without any internet connection required. We also support log clearance after a flight. These logs are created for after sales team to help with any issues. However, if you are not comfortable with the logs being saved onto the device locally, you can go ahead and clear those. It is important to note if you do clear the logs though, after an error or accident, your after sales rights may be affected. You can also encrypt an SD card in case the drone were to be lost or stolen. No one else would be able to access what's on that SD card without the DJI decryption tool and the password that you had set. This DJI decryption tool only supports the Windows operating system. Another key component for the M300 series and DJI aircraft is network security mode. Overall, we support three network security modes and individual service options. The first one being standard mode, which allows the DJI Pilot 2 application to connect to the internet normally. for items such as map service or network RTK. Restricted network mode doesn't allow any requests except for map service, network RTK, and live streaming. And then local data mode would be for no network requests to be sent in order to protect your data. Overall, we do support offline maps as well and the DRTK2 base station. So this does allow for options if you do want to utilize local data mode and still see those up-to-date maps and utilize RTK. However, many operators find it convenient to utilize the internet for these type of features. Now moving into advanced intelligence for the system. Going to talk about Pinpoint, Smart Track, and some of the location sharing tools that are important when collecting aerial intelligence in missions. First off, let's take a look at the Pinpoint feature. This allows you to create a pinpoint, which you can think of as a GPS location with the laser rangefinder. So here we are zooming in. Click the pin button in the top left. You can see that's placed on the screen. On the map, we can now see the pinpoint location along with the distance away from the drone. You can also move the camera away from the pinpoint, and by clicking the eyeball next to the pin itself, the camera will snap back to what you had marked. Excuse me. Smart Track is another feature when you turn it on by clicking the circle with the dot within it. The gimbal is going to automatically detect objects such as vehicle, people, and boats. You can go ahead and tap one of the green circles for smart tracking to start. At this point, the drone will yaw left and right, and the gimbal can also automatically move. However, the drone is not going to fly. If you'd like to fly the drone to help keep the object in visual sight for the camera to track, that is something you can do. While smart tracking is taking place, you will be able to see the location live on the screen if you turn on the laser rangefinder or in the map interface. By connecting to DJI Flight Hub 2, our cloud-based system, you can see this location information and live streaming view in real time. Here in the top right, you can see the ability to draw lines, drop pinpoints, or polygons, which can then be synced to the controller of the drone operator. And likewise, as the drone operator, you can also see a live stream within Flight Hub 2 that goes along with the current drone location and shows where the laser rangefinder is looking at. Moving into Smart Inspection with the H20 series, which supports both live mission recording and AI spot check. You can think of live mission recording as step one, and AI spot check as something that we can build onto this. Live mission recording is an easy way to create automated flight missions. Whenever you take a photo or record video as an operator, the drone will automatically add a new point, which we call a waypoint. You can think about it as a GPS location and action that the drone is going to remember. After you fly an inspection once manually, a waypoint inspection will be created to then automate that mission in the future. The idea here is that after flying a mission once, you'll want to collect the same data again and again. AI spot check is an addition onto this basic live mission recording. So after a photo is taken, you can go ahead and annotate. In this case, right above the insulator here is the area of interest. So when the drone goes back to take that photo, make sure it's retaking the same photo. So once again, can think about this as two layers. We fly our mission once. The drone's going to remember where we took photos at, those exact locations. You can also add drone locations for it to fly to without taking a photo. You can then annotate those photos after the mission with AI spot check, and then repeat the video, repeat the process again and again. Another option we have is high-res grid photo. You are able to draw a grid on the screen itself, and each of those boxes you see within the grid is going to be a high-resolution zoomed-in photo, which you can review on the photo on the computer after the fact. You'll have the overall grid photo. You'll be able to click on individual photos. And this is beneficial because instead of having to zoom in and take those individual photos or just having one wide photo, you have detailed information about the entire asset that is within the grid that was drawn by the operator. So once again, in this case, it is this transmission pole that's being collected, and then we can click on one of those individual grid cells, and now we have that 20 megapixel photo from the zoom camera to look at in more detail. We spoke about this a bit earlier, but the operator will be able to see the primary flight display when in the FPV view that's built into the drone. You can see in the bottom right, you can switch over to the payload camera, but right now we're in the FPV view that's built into the aircraft. We have some different options here you can see. We're able to see any vertical obstacles below or above the drone. We can see our current altitude, the vertical speed and absolute altitude, our horizon and flight path vector. So you can see this is where we'd end up if we kept the same control inputs. And we'll play this one more time so you can see horizontal speed, wind speed and direction, and then within the navigation display, you can see any obstacles around the aircraft in real time. Then we talked about earlier, you can customize those distances so you can get closer to objects or stay farther away depending on your mission. Dual control, we spoke about this a bit earlier, but just a reminder, you can lock control so you can have only one person flying. This is also a useful tool for training, where you can have a new operator flying and then a more experienced operator ready to take control at any time. Taking off in one location and landing in another by transitioning the drone from one operator to another is also possible. Finally, let's cover extensibility and openness of the system. DJI SDK supports both mobile applications that can be developed and run on the controller, onboard SDK, which can be added on to the drone, and payload SDK. Recently, our onboard SDK has been merged into our payload SDK as well. Some of the third-party payloads include spotlights, multispectral sensors, 5-lens oblique cameras, and gas detectors. Once again, this is one of the big pluses of the Matrice 300 series, is the different ability to swap different payloads in depending on the mission set, and additional payload capacity to use multiple payloads at the same time. Overall, our global adoption of the DJI SDK continues to scale up with developers, apps, payloads, and Cloud API developers. Speaking of the Cloud API, this allows operators to keep using the native Pilot 2 app if they choose to do so, while pushing important information like photos, videos, or live telemetry information to a third-party server. The advantage of this would be complete privatization, customization support, and high compatibility across the latest versions of DJI Enterprise aircrafts. Let's review some of the key specs and accessories for the M300 series. Weight is going to be about 6.3 kilograms without any payload, with a max takeoff weight of 9 kilograms. Max flight time with no payload is 55 minutes. Max speed, 23 meters per second. Our max ascent and descent speed would be 6 and 5 meters per second. A max service ceiling of 7,000 meters. You can also purchase propellers for operations at higher altitudes where the air is less dense. Max wind resistance of 15 meters per second or 33 miles an hour. Supports payloads including the H20 series, the H20N, the P1, L1, and third-party payloads through our payload SDK. Ingress protection for the aircraft of IP45, operating temperature of -20 to 50 degrees Celsius, and a maximum transmitting distance of 15 kilometers based on FCC standards. You will need to utilize an aircraft itself, the BS60 battery station to charge the TB60 flight batteries, which you utilize 2 of in flight with the M300. And finally, the Smart Controller Enterprise, which is compatible with the Matrice 300 RTK. This drone will be compatible with the DJI RC Plus in the coming months, which currently works with the Matrice 30 series. A couple key use cases we see for this aircraft and payload include law enforcement for Overwatch, with a long flight time, strong zoom capability of the H20 series, the ability for the aircraft to have a lower noise, and also the ability for discrete mode to turn off any lights on the aircraft if allowed based on local regulations, ability to quickly charge batteries with the BS60, pinpoint locations to share to team members or to easily come back to as the pilot, and different payload configurations, including powerful spotlights that can go along with the H20 series. Some of the benefits for operators include the ability to continuously observe an area, far remote evidence capture, where the drone can maintain a long standoff distance, and overall, don't want to disturb people or in potentially confidential situations. Once again, here you can see the detail of the wide camera, the ability for the zoom camera to zoom in on an area and collect important details for a team, whether that is a SWAT team in more of a potential standoff scenario or a search and rescue team searching for someone who is lost or someone on the run. Another key area here is inspections and specifically electric utilities. The powerful zoom sensor with the 20 megapixel camera leads to quality photos at a long, proper standoff distance for the drone, while being able to capture thermal data with a 640 by 512 thermal camera at the same time, which can be analyzed after or during the mission for any anomalies. Overall, this hybrid sensor, collecting multiple information at one time, allows for efficient operations overall, along with some of the important flight modes we talked about, including the ability with smart inspection planning and AI spot check to fly a mission once and then repeat it again and again. Thank you for tuning into today's session on the Matrice 300 series and H20 series. Have a good one.